A tank contains 100 gallon of pure water. So here is the case. So we have a tank containing 100 gallon of pure water. So initial amount of sugar is 0. Okay, and it says a sugar water solution containing 0.4 pounds per gallon, that's the concentration, enters the tank at a rate of 3 gallon per minute. Okay, this is the flow rate in, and simultaneously a drain is open at the bottom of the tank, allowing the well stirred sugar solution to leave at 3 gallon per minute. So we need to find the concentration of the leaving sugar solution. So the concentration is always given by amount of sugar divided by the volume. So in this case we assume, as usual, let Qt be the amount of sugar in the tank at any time t, and then initially there was a pure water. That means the amount of sugar when time is 0, that's 0. The sugar amount is 0 when time is 0. So at any time t, the sugar amount is Qt. That means the concentration will be then amount of salt Q at any time t divided by the volume of the water, which is 100 in this case. It's fixed because the water, this mixed sugar solution, is getting in at the rate of 3 gallon per minute and getting out at the same rate. So it's 100. Okay. Then this process can be modeled using the following differential equation. The rate of change of sugar content at any time t, dq over dt, is this flow rate. So we multiply these two. So 0.4 times 3 minus flow rate out. So just rate out. So 3 times this. 3 times, I'm going to drop t, just write on q over 100. Okay, qt means q as a function of t. And now let's solve this equation. In fact, this is a separable as well as linear. I want to make it linear. Bring 3q over 100 to the left side. So dq over dt plus 3 over 100q equals multiply 1.2. This is a linear ordinary differential equation in q with respect to t. In q with respect to t. Okay. To solve this linear differential equation, we find the integrating factor. Integrating factor mu as a function of t is given by e raised to antiderivative of this coefficient, which is positive 3 over 100 with respect to t. That is, integrate this, we can pull this outside. Antiderivative of 1 is just t, so 3 over 100t. Now we multiply this differential equation both sides by the integrating factor. Then the ODE becomes, okay, left hand side will be automatically the derivative of the dependent variable q times the integrating factor e raised to 3 over 100t is equal to, multiply right hand side, 1.2 times e raised to 3 over 100t. Now integrate both sides. Okay, integrate, then we get q times e raised to 3 over 100t equals, we integrate, so 1.2 constant survives, e raised to 3 over 100t divided by this constant, right? For e alpha t, antiderivative of e alpha t is itself divided by that alpha, which is 3 over 100 plus arbitrary constant c. Okay, now let's divide both sides by e raised to 3 over 100t to isolate q. Okay, so divide both sides by e raised to 3 over 100t, we get q as a function of t equals, if we simplify, 1.2 divided by 3 over 100, 100 goes on the top, 120 divided by 3, that will become 40, and divide by this cancel, plus divide c by this, so c divided by this exponential function, which is same as e raised to negative if you take to the top. Okay, so now using the initial condition, that means the initial amount of sugar, we can determine the value of C. So using Q at 0, when time was 0, the amount of sugar was 0, we get Qt is 0 equals 40 plus C times e raised to 0, which is 1. Move C over, that is C equals negative 40, or C equals negative 40. Okay, so let me go here. Thus we found the amount of salt at any time t. Qt is given from here, okay, just from here, and we just found the value of C, negative 40. So 40 minus 40, C is negative 40, times e raised to negative 3 over 100t. Now we can answer the 3 parts. Okay, in part 1 we are asked to find the sugar content in the tank after 15 minutes. So this is the amount of sugar at any time t. So after 25 minutes, just replace t by 25. So Q25 is equal to, just plug in t equals 25 and use your calculator, and it comes out to be 21, around 21.1. So 21.1 pounds. In part 2, the question asks how long will it take the solution content in the tank to reach 30 pounds. So we need to find the time to reach the sugar content to be 30 pounds. So in the same formula, because we're going to use this amount of salt, sugar at any time t over and over. In part A we just replace t by 25. In part B now we know the amount of sugar content, that's 30 pounds. So this is 30. We want to find the time. 30 equals 40 minus 40 e raised to negative 3 over 100 t. We want to determine this t. Subtract 40 from both sides. So 30 minus 40, negative 10, equals negative 40 e raised to negative 3 over 100 t. Now divide by this number, negative 40. So negative 10 divided by negative 40, so 1/4, equals e raised to negative 3 over 100 t. Okay, to get rid of this natural e, take natural log both sides. So natural log of 1/4 is, when we take natural log, cancels, so negative 3 over 100 t, and that implies t equals, now divide natural log of 1/4 by negative 3 over 100. So natural log of 1/4 divided by negative 3 over 100, and that will be in terms of minutes. Okay, just use your calculator and find in terms of minutes, and it gives the calculator gives you 46.21, about 46.21 minutes. Okay, 46.21. Now let's look at the third question. What will be the eventual, that means when we let this process go or run forever, when t goes to infinity, the sugar content. So let's take the limit of this function, okay, when t goes to infinity. So in part 3 we want to find the limit of Qt when t goes to infinity, which is same as limit of, let me write down here, that is same as limit t goes to infinity of Qt is 40 minus 40 e raised to negative 3 over 100 t. Okay, when t goes to infinity, this becomes e raised to negative infinity, and e raised to negative infinity is 0. So this is gone, so we have only 40. So the eventual content is 40 pounds. Okay, final.